Hey, welcome back. Let's take a look at the unique measurement of chemistry called the mole. The mole is just like any other unit. It means a number. So you may say 12 equals a dozen, but in this case, I'm going to say 6.022 times 10 to the 23rd equals a mole. So as 12 is a dozen, 6.022 times 10 to the 23rd of anything is a mole of that thing. This number is often referred to as Avogadro's number because Avogadro was a part of the research of this number. So the majority of this work was based upon carbon 12 to be precise. And they basically said that 12 grams of carbon has 6.022 times 10 to the 23rd atoms in it. So anything that is 6.022 times 10 to the 23rd is 1 mole. If I had 1 mole of basketballs, how many basketballs would I have? 6.022 times 10 to the 23rd. How big would this be? How big of a bag would you need to put this many basketballs in? You would need a bag the size of the Earth. Okay, this number is very, very large. But it's okay because atoms are so small. So when we use things like basketballs, we can see how huge it is, but atoms are so ridiculously small that this number works. Now, let's say I was going to look at the periodic table. We remember that at the bottom is the average atomic mass. Every element has an average atomic mass at the bottom, and this represents 1 mole of that element. And 1 mole is 6.022 times 10 to the 23rd. So every time I have 12.011 grams of carbon, I have 6.022 times 10 to the 23rd atoms of carbon. Same is true for oxygen. Oxygen has a mass of 15.99 grams. So that means every time I have 15.99 grams, I have 1 mole of oxygen, and I have 6.022 times 10 to the 23rd atoms of oxygen. So if I was going to write this as a molar mass, all I'm going to think about is the mass per 1 mole. So there was a 12.11 grams was the average atomic mass on the periodic table. So if I'm going to write this as a molar mass conversion, 1 mole of carbon over 12.011 grams of carbon. That is the molar mass of carbon. I can also write it with the carbon on top. 12.011 grams of carbon on top, 1 mole of carbon on the bottom. Okay, so let's take a look at 32 grams of oxygen. And they're asking me for the number of moles in 32 grams of oxygen. So I will rewrite the given, which was 32 grams of oxygen. And now I'm going to need a conversion factor. You may remember this from the conversion factor video. That conversion factor is going to give me the units I want, which is moles. Therefore, I'm going to put moles on top. and I'm going to put grams on bottom so that my adjacent cancels and my answer units are on top. Now, if I were to look this up on the periodic table, I would find the number 15.99 for oxygen. So that is what I'm going to put for grams for oxygen, because that's what the periodic table says. And I will put 1 for moles always when I'm dealing with molar mass. And so when I do the math, I'll divide because of the math, and I end up with 2 moles of oxygen. That's it. See you next time. Bye-bye.